Hello, good morning everyone. Today we discuss about metal clusters. Again, in examination they ask what is the factors favoring metal bonding in metal clusters. So we have two factors. First one is internuclear distance is less than sum of the radius, and the second one is decreasing magnetic momentum. How we can explain? For example, in rhenium metal, you take these two rhenium atoms in free state. The internuclear distance means here one of the radius is r1, you write, here the second one is r2. So here the distance between this radius, this nucleus to this nucleus. So this is called as internucleus distance. So here the r1 and plus r2 is more compared with the internuclear distance. In the metal crystals, the crystal is takes side by side. In this case, the R1 and R2 is side by side. So here the internuclear distance is equal to the sum of radius. But in case of a trinuclear metal cluster of rhenium, the internuclear distance is 2.48, whereas sum of the radius is 2.75. So it is one of the evidence the internuclear distance is less than sum of radius. The second example is rhenium 2 Cl8 is nothing but octachloro rhenium 8 plus 3 ion. So in this case the internuclear distance is 2.24, but here the sum of radius is 2.75. So there is a second example to give the evidence for the internuclear distance is less than the sum of radius. The next one is decrease in magnetic momentum. So how can we explain the decrease in magnetic momentum? Here we already know the 3D and 4D and 5D series. In the 3D series, the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Whereas 4D series, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, and cadmium. Whereas 5D series lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, and mercury. So here the example, we don't write exact the atomic number, just you write that like the series, and you write it is a 3D D5 series in this manganese, technetium, and rhenium. So you write the configuration Re6s2 5D5. Why? Because the configuration is general configuration NS2 and -1 D1 to 10. So here again we calculate what is the oxidation state of in cluster of rhenium. So we have two types of chances. Based on the monomer, we can write ReCl4 minus X minus 4. So because chlorides are negative charge. Again, what is the charge given in the top of the sphere? We write the same with charge -4. By -4 comes it this side, it becomes +4. The total is +3. So based on the directly cluster, we can calculate 2x minus 8 minus 2. 2x is equal to -2. The -8 is becomes like this +8. Again +6. 2 monomers, 2 rhenium atoms is +6. So the one is +3. So based on the configuration, we can write 6s2 5d5. So here the configuration again our favorable, you can write addition means 6s2 is outer shell, 5d is the inner shell. Most of the students done mistake, we remove the electrons from these 5d5 of the 3 electrons, so it is a wrong answer. So that's why you write for the again configuration 5d5 6s2 and loss of 3 electrons. First you remove from cx 6x2 and we remove an electron from the 5d. So these 4 electrons in the inner shell of rhenium. So 1 2 3 4. So each rhenium has 4 electrons. So if the exam 4 electrons, it is a magnetic moment is very high. But it is tier 2 rhenium atoms and overlap in the sigma bond and pi bond and 2 pi bonds and 1 delta bond. So all the 4 electrons involved in the bonding. So there is no unpaired electron. So the magnetic momentum is nearly 0. So that is the second evidence, decrease in the magnetic moment.